Welcome. In today's lesson, we're going to talk about density. Our target is to understand how density is determined and be able to calculate the density for various objects. Throughout this video lecture, you should be taking notes on the formula for density and what physical properties determine an object's density. Let's get going. So density is a comparison of how much matter there is in a certain amount of space. So inside matter, there's atoms, and the atoms move around, and we want to know how many atoms are packed into a certain space. So here's an example. Pretend these little purple dots are people in a square, and we want to know which one is more dense. Square A or square B. Which one do you think is more dense? So square B is more dense because there are more people packed into the same size square than square A. Let's try another one. Now, which one of these is more dense? A or B? You'll notice that each square has 5 people packed into the square, but the squares aren't the same size. Square A is clearly smaller than square B, which would mean that square A is more dense. So density is how close or tightly packed those atoms inside a substance are. We calculate density by taking our mass divided by our volume. One trick that I remember to calculate the density is that we love density. So if you take a heart and we cut it in half, it is mass divided by the volume. We learned in our measurement unit that the units for mass are grams, and the units for volume are centimeters cubed or milliliters. So when we take our mass, which is our gram, and divide it by our volume, which is in centimeters cubed or milliliters, we are going to get grams per milliliter or grams per centimeters cubed. Please always remember to put your units on your answers. If we don't remember to put our units on our answers mean nothing. Let's try a problem together. So Frank has a paper clip and it has a mass of 9 grams. We're going to underline our knowns, and a volume of 3 centimeters cubed. And it wants to know what is the density. So we know from our formula, density equals mass divided by volume. We can plug in our numbers. We know that we have a mass of 9 grams divided by a volume of 3 centimeters cubed. Nine divided by 3 is 3, and we get to keep our units here, grams per centimeter cubed. Frank also has an eraser. It has a mass of 3 grams and a volume of 1 centimeter cubed. What is the density? Again, we know that density equals mass divided by volume, which equals a mass of 3 grams divided by a volume of 1 centimeter cubed. Three divided by 1 is 3. And our units again, grams per centimeters cubed. Grams per centimeters cubed. So the density of Frank's paperclip and his eraser are both 3 grams per centimeter cube. Try these problems with your neighbor on your desk and insert the answers in the boxes. Jack has a rock. The rock has a mass of 6 grams and a volume of 3 centimeters cubed. What is the density of the rock? Jill has a gel pen. The gel pen has a mass of 8 grams and a volume of 2 centimeters cubed. What is the density of the gel pen? Now try these problems. Alicia has a watch. It has a mass of 4 grams and a volume of 2 centimeters cubed. What is the density of the watch? Mia has a wallet. It has a mass of 15 grams and a volume of 5 centimeters cubed. What is the density of the wallet? When we talk about liquids, it's easier for us to determine the density of our liquids because sometimes when we pour them together, they don't mix. Like water and oil won't mix because they have different densities. So if I have a cup of water here, if I pour oil into the water, what's going to happen to the oil? Right, it's going to float on top of the water because the oil has less density than the water. So the liquid with the highest density will be on the bottom. Oops, let's use the same color. And the liquids with the lowest densities will float to the top. Here's a picture of some densities over here. Again, the highest densities will go to the bottom and the lowest densities will go to the top. Check out this picture. That's not from our book, but from a book. Which layer has the highest density? Which layer has the lowest density? Imagine that the liquids have the following densities: 10 grams per centimeters cubed, 6 grams per centimeters cubed, 3 grams per centimeters cubed, and 5 grams per centimeter cubed. Which number would go with each layer? Here's another picture, another practice. Which liquid has the highest density? Which liquid has the lowest density? Which liquid has a middle density? We're going to try another one here. So imagine that we have the liquids on the right and we know some densities. We're going to try to match them with their correct color. Green, tan, red, blue, clear, and brown. Please try these review questions to complete the lesson. Which is the formula for density? What happens if you pour together liquids that have different densities? Will the liquid on the top have the highest or lowest density? Will the liquid on the bottom have the highest or lowest density? Thanks for watching. See you next time.